fashion. So first point is for traveling over longer distance. So this is the point we are discussing since the start of this lecture. Whenever you are modulating the signal, the baseband signal can travel for a longer distance. Second point, for noise effect reduction. This is another theory in case of communication engineering, very important, which says that whenever the signal frequency is less, it is getting affected by high frequency noise more. If the signal frequency is higher, then the effect of noise is less. So we are encapsulating the low frequency baseband signal with high frequency carrier signal. We are increasing the frequency of overall signal, modulated signal, so that it can travel for longer distance, and effect of noise, the negative effect of noise on the modulated signal will be less. So that's why the effect of noise on modulated signal is less. So what we say is proper reproduction of baseband signal at receiver possible with modulation. This is the second point, very important point. Third point, which is very important, there is a very small formula to explain that. It is called as modulation. Modulation helps reduce antenna height. There is a small calculation for that. It is saying that the antenna height for transmission and reception, antenna height, that means the height at which the antenna is to be kept fitted among a tall building or maybe with some tower and all. So that height is a function of its lambda and is given by lambda by 4. Okay. So what is lambda? Lambda is baseband, or lambda is signal frequency. Okay. Now we know that lambda is equal to C by 4f, so there should be a C. So lambda is equal to, we know this formula that lambda is equal to C by f, where C is 3 into 10 raised to 8 and f is the signal frequency, like this. Okay. So this is a standard formula. Whenever I am saying that a signal is having a certain frequency, it's having a certain lambda, what should be the antenna height if we want to transmit that signal to a longer distance? In that case, the antenna height is calculated from the formula of C divided by 4 lambda. So this formula is actually a little mistaken. So this is C divided by, antenna height is given by C by 4. Okay. So please correct it. So antenna height is given by C divided by 4f, and actually this is equal to lambda by 4. Okay, because lambda is equal to C by f. Now the whole thing is correct. So I wrote this thing first, but actually this thing we can take like this. So antenna height for transmission and reception, we can say it is lambda by 4. Lambda can be substituted by C by f from this formula. Now just do a very small numerical. If I want to transmit 300 Hertz signal, in case 1, if we want to transmit 300 Hertz signal, it's audio frequency signal, what should be the antenna height? So in this case, to transmit 300 Hertz signal, the antenna height, so this is now the baseband frequency, or this is the modulating signal. This is baseband frequency, or this is the modulating signal. I just want to transmit this thing directly without modulation. Then just check how much is the antenna height. In this case, antenna height will be C is 3 into 10 raised to 8 meter per second, and this is 4, and F is nothing but the frequency of baseband signal. So how much is that? That thing is nothing but 300. So just check how much is this. So this 303 into 10 raised to 8. So if you just check that, so 300 into 10 raised to 6 divided by 4 into 300. So this 3 into 10 raised to 8 I can write as 300 into 10 raised to 6. Now this 300 gets cancelled. Okay. So now this will be 10 divided by 4 into 10 raised to 5. So this will be 2.5 into 10 raised to 5 meter. Just imagine 2.5 into 10 raised to 5 meter. So how much is this? So this is 2.5 into 1000 into 100. So this is meter. So this is multiply this thing. So this will be 2500 into 10 raised to 2 kilometer, like this. So this will be the antenna height. This is something very high figure, so we cannot fit antenna at that height. Okay. So what we find is, if the baseband frequency is 300 Hertz, at that time antenna has to be fitted at a height of 2500 into 10 raised to 2 kilometer. That height we have to keep the antenna, or multiples of that. Not possible. What in the second case you do is just modulate this baseband signal with a 3 megahertz carrier signal. Okay. So if I am saying that modulating signal baseband is 300 Hertz, carrier is 3 megahertz, modulated frequency is also 3 megahertz. And within this modulated 3 megahertz, all the characteristics of that 300 Hertz modulating signal is kept intact. So it's just nothing but a encapsulation process. So in this case number 2, whenever I am saying that I am increasing the modulated signal frequency to baseband signal of 300 to 3 megahertz, at that time how much will be the antenna height? So in that case, only this thing will change. So this will be 3 into 10 raised to 6. So 3 megahertz means 3 into 10 raised to 6. So in this case 3 into 10 raised to 8, this is 3 into 10 raised to 6. So if we cancel this, what it will become is 100 divided by 4. So this will be around 25 meters. So that's it. So 3 into 10 raised to 6 and 3 into 10 raised to 8. So 3 into 10 raised to 6 gets cancelled. Only 100 remains there, divided by 4. Whatever is the numerical saying, the main agenda, what we are finding, the main point what we are finding is, if we are increasing the frequency of the waveform, we are finding that antenna is kept at a lot lesser height. Many examples can be asked on this in exam, so prepare this. Only formula you have to remember is antenna height is C divided by 4f, or it is given by lambda by 4. Okay. And lambda is given by C by f, where C is the frequency speed of light and f is the frequency. Now keep on changing this frequency from very low to very high value, you will finding that the antenna height will keep on reducing, and that is only possible through modulation, that keeping the signature of the signal intact and reducing the antenna height. So this is the third point and very important point, that is modulation help us to reduce the antenna height from a very unrealistic height to a realistic height. So previously we found it was 2500 into 100 kilometer. If you are increasing it to the modulated frequency, it is reducing to 25 meters. 25 meters is easily achievable. Fourth point, modulation avoids mixing of signals, and this is avoids chaos, and this also helps in proper reproduction. Let's say there are not only one signal, there are 3 or 4 different signals, there are 3 or 4 different people singing at the same time, and all those 4 singing signal, all those 4 audio signals we want to send at 4 different parts of the country through the same antenna we want to transmit it. So what we do is, this is baseband signal 1, this is baseband signal 2, this is baseband signal 3, and this is baseband signal 4. Now use it at 3 megahertz, let's say 4 megahertz, 6 megahertz, and 8 megahertz. So this is baseband signal, and these are 4 different carrier signals, like this. Okay. And then this is singer 1 is, his voice signal is modulated with 3 megahertz, singer 2 voice signal is modulated with 4 megahertz, singer 3 with 6 megahertz, and singer 4 with 8 megahertz. Now after modulation, this to become one signal modulated with 3 megahertz, modulated, this to become one signal with 4 megahertz, modulated, this to become one signal with 3 megahertz, and this becomes modulated with 8 megahertz signal. Now if we mix them, that 3 mega, 4 mega, 6 mega, and 8 mega, there are different mixing techniques, multiplexing techniques, and we send them. At the receiver side, the first thing the receiver will do is, first receiver will take out or filter out the 3 megahertz signals, and after filtering out the 3 megahertz signal, the voice signal of singer 1 will be taken out from the modulated frequency of 3 megahertz. So this is done by filter. Second case, another receiver is tuned for filter of 4 megahertz, so that will take out only the 4 megahertz signals from that complex signal of 3, 4, 6, and 8 megahertz things. So it will just take out the 4 megahertz signal, and then the second singer voice will be taken out from this 4 megahertz signal by the process of demodulation. So these are the things that happens in case of modulator and demodulator case. So this is a very important point, which says that modulation and obviously demodulation avoids the mixing of signals. Last point, point number 5, it says that it increases the range of communication, multiplexing is possible. So that is another very important thing. This is called multiplexing. Multiplexing is possible and modulation helps that. So what are the different types? What is meant by multiplexing? Multiplexing is nothing but sending many signals over a simple channel simultaneously. So simultaneously means not always, it is not always with time. Okay. The same channel can be used to transmit many signals. So there are different types of multiplexing. One is called as time division multiplexing. So in this case, one signal is sent at a time. So suppose there are 4 signals. When first signal is being sent for suppose 1 millisecond, second, third, and fourth are idle. Then in the next millisecond, the second signal will be sent. In the third millisecond, the third signal will be sent. Fourth millisecond, the fourth signal will be sent. And then again in the fifth time slot, the first signal will be sent likewise. And at the receiver side also, the receiver has to catch the signal like that. That is first, fifth, 9th, 13th. Those are the time slots if we want to catch the first signals. Second, 6th, 10th, 14th. Those are the time slots if we want to catch the second signal, and so on. So this is called as time division multiplexing. And before multiplexing, signals are modulated. So there is time division multiplexing, there is frequency division multiplexing, there is code division multiplexing. All are different multiplexing techniques we will be studying in the future. So these are all possible